section 7.5, apply the tangent ratio. A trigonometric ratio is a ratio of the lengths of two sides of a right triangle. You will use trigonometric ratios to find the measure of a side or an acute angle in a right triangle. The ratio of the lengths of the legs in a right triangle is constant for a given angle measure. This ratio is called the tangent of the angle. So let triangle ABC be a right triangle with an acute angle, angle A. The tangent of angle A, written as tan A, is defined as follows. It's the length of the leg opposite of angle A over the length of the leg adjacent to angle A. So in angle A, the leg opposite of that is the one that does not touch it. And the adjacent leg is the one that makes up the angle with the hypotenuse. So the tangent does not use the hypotenuse, it only uses the opposite and the adjacent. So using the tangent ratio, okay, so we want to find the tangent of D and the tangent of F. And we're going to write each answer as a fraction and not a We're going to write each answer as a fraction and as a decimal rounded to 4 places. So the tangent of D, we're going to do our opposite leg, which is 60, over our adjacent leg, which is 45. We're going to write that in simplest form. We can divide both by 15 to get 4 over 3. And as a decimal to 4 places, we're going to say 1.3333 because it continues repeating. So it's approximately, we could actually say approximately equals there. Tangent of F, again, we're going to do the same thing, but this time the opposite side is 45. And our adjacent side is 60. This simplifies to 3/4, and as a decimal to 4 places, it's 0.7500 because it just ends up being 0.75. So we'll put the 2 zeros, so we got 4 places. So for the next one, we are given an angle measure, one of the lengths of our legs, and then we are looking for the length of the other leg. So to find the value of x, we're using the tangent ratio. Tangent of 17 degrees is equal to the length of the leg opposite of 17 degrees, which is your 9, over your adjacent leg, which is x. So you can think of this as proportions to solve it. If you put this like over 1, you get cross multiply, so you have 1 times 9 equals x times the tangent of 17. And then you're going to divide both sides by the tangent of 17. I always just remember these switch places. So my x comes here, and the tangent goes on the bottom. So here's where you're going to use your calculator. Make sure your calculator is in degrees. If you haven't really done anything with it, it probably is in degrees by default. On the 84, if you need to put it into degrees, you want to go to the mode button, which is right next to the second button. You would go to mode, and the third thing down says radian or degree. Make sure degree is what's highlighted. And then you can do second mode to get out of there. So then you're going to do 9 divided by, and then you're going to use the tan button, and then you're going to type in 17, close the parentheses, and you're going to get an approximate answer. Let's just tell it to round 29.4 degrees. On the Inspire, it's a little bit different. If you're not sure on the Inspire, if you're in degrees or not, there's a way to do that. So you would go on here You can actually, you could do it as a fraction if you want. As a fraction would be control, which is the blue button, and then the division sign, and that'll set it up as a fraction. Can't really see it on there. I don't think it shows up. And we're going to put 9 as our numerator, and our denominator. To find tan, you want to go underneath the control button. There is the equals, and next to it is trig, and you want to select trig, and you want to go over and find tan. Hit enter. And then you're going to type 17, and then to make sure that it's in degrees, you're going to go to control, and then this button right here, which is just underneath delete. It's the little book. Above the book it says alpha, beta, degree. You're going to go to that, and you're going to go all the way to the right and select degree. Hit enter, and now it has 17 degrees, and then you can hit enter again to evaluate it, and you get 29.4 degrees. Okay, so now we're going to estimate height using tangent. So we want to find the height of a flagpole to the nearest foot, and we are given the 65-degree angle, and that this length is 24. So we're going to set up our tangent ratio. So tangent is the opposite leg, which is x, over the adjacent leg, which is 24. We're going to multiply both sides by 24 to get rid of that there. So we have 24 times the tangent of 65. So again, I'll go through on the Inspire. You're going to type in 24, and then underneath control, next to the equal sign is trig. You're going to press trig, select tan. You're going to type in 65, and then you're going to go to control, the little book, which is underneath the delete button, and select degree. And then you can hit enter, and you should get 51, about 51 feet. 51.4682. Okay, so then the final example is using a special right triangle. So these you're not going to use the calculator on, because you want to get the exact value. You could find it on the calculator on this one. A lot of the special right triangles, though, have square roots, so you have to be very careful. So we're going to use a special right triangle to find the tangent of a 45-degree angle. You can put x's in there, x squared to 2, because when you're doing the ratio, the x's will cancel, so it won't really matter. But then it gives you something to write there. So tangent of 45 degrees, you pick one of them that you want to use. So let's pick this one here. The opposite side is x. The adjacent leg is x. X over x is 1. So the tangent of 45 degrees is 1.